Hello, Edward here from 088. In this session, we're going to be talking about using streaming ACN and ArtNet with your flex range lighting console running Zeros. So if we just take a look at the console, I'm currently running Phantom Zeros. Phantom Zeros is free software that you can download from our website, and it allows you to emulate any console running the Zeros software. I'm currently emulating a Flex console, so we're seeing here what I would see on my external monitor. So if I go into Setup on my console, and I then go to Universes, this is where I can go and choose how I can route my lighting control data from my console out to my lights. And by default, you will of course have DMX enabled. DMX being our predominant main method of controlling our fixtures. So before we dive in to look at streaming ACN and ArtNet, let's just remind ourselves a little bit about what we have with our DMX. So for our DMX, you might be familiar with the fact that you've got a maximum of 512 channels down our DMX cable. That's why it's called DMX 512, 512 control channels. And of course, when we're talking generic dimmer channels, typically they're just a single channel per light. But when we're talking about moving lights are going to use multiple of these channels. So you will start to eat into that block of 512 channels quite quickly. As well as that, on your one DMX line, from the DMX source, you can have 32 fixtures daisy-chained onto that DMX line. Now, you can use something called a splitter or a buffer to then boost that signal up to give you another 32 devices. But that splitter is not going to give you more channels. With DMX down the one cable, known as our universe, a universe of DMX is a block of 512 channels. So if we run out, well, we're going to need to run another cable. And this is where we start to see the benefits of the streaming ACN and ArtNet protocols. Because streaming ACN and ArtNet can be used to transmit multiple blocks of 512 over Ethernet. So they can transmit and send multiple universes of DMX over our Ethernet network. So probably a good question is, well, okay, why then? So that first point there, as we've mentioned, it allows us to send more than 512 channels. When I say more, we're talking thousands more. And we'll get to that in a bit. Why move over to Ethernet? Well, of course, Ethernet is everywhere. Networking is used by many other industries far larger than the entertainment industry, and so we can kind of piggyback and use all of that infrastructure and technology that's already exists. Now, of course, as soon as we're on Ethernet for our lighting data, for our ArtNet and streaming ACN, well, we can also use other stuff. There's just some bullets there of things that when you're on Ethernet allow you to do. Of course, connecting the remote apps is something that really simple. As soon as you're on a network, you'll be able to do that. So let's just very quickly talk about some of the connectors, the hardware, if you like, when it comes to using streaming ACN and ArtNet. So on the rear of your console, you will have either one of these types of connectors. If you're on the full-size Flex, you're going to have an Ethercon connector, a female Ethercon connector, and that allows you to plug in a male Ethercon connector, which looks like that. But as well as being able to plug in the Ethercon connector there, you can also plug in your standard RJ45. So you can plug in either of those connectors into the rear of the Flex. The Ethercon is just literally a RJ45 in your kind of XLR chassis, if you like. And so it's a much more rugged connector. What you find all the time is with your RJ45 connectors, your little plastic clip snaps off, and then the cable easily wiggles free from the connector, and that's never a good thing, especially when it's running your lighting. So that's why EtherCon kind of exists. It is needed for that rugged and properly mated connector. But for when you're on FlexS, you do just have your RJ45 socket on the rear, which you can use. So that's all well and good. We're on our Ethernet network. That's lovely, happy. We're using streaming ACN and ArtNet. We'll talk about how we can configure it in a bit. But just big picture, first of all, how do I get my network to plug into my light? How can I actually plug in my streaming ACN signal and plug it into my light? Well, first and foremost, a lot of lights nowadays, a lot of fixtures have a network port on them. You can connect straight from your console to a fixture over the network, over Ethernet. A lot of fixtures will have that EtherCon or RJ45 connector straight on board. But they don't have to. And if your fixtures just have normal DMX connections, plugging into a dimmer pack, a beta pack, for example, or you're plugging into a fixture, LED or moving light that just has a DMX connector on it, you can use one of these. You can use a gateway, a Ethernet to DMX gateway. These are the two that are from 088, the Gateway 4 and the Gateway 8. And both of those can convert, if you like, your streaming ACN or ArtNet to the DMX signal. And either gateway can do that. Of course, you don't just have to use the 088 ones with your console. Streaming ACN and ArtNet are two protocols widely used in the entertainment industry. So many other gateways will be able to take streaming ACN or ArtNet and convert that to DMX, and you can then run your DMX lines from the gateway. So a very typical setup of how that might look, kind of talking from a theatrical point of view. Console at the back of the venue, one run of Ethernet network to side of stage, and then plugging into one of these, and you then break out side of stage to your DMX lines. Saves you having to run a whole bunch of DMX cables from the back of your venue to side of stage. As well as using gateways and plugging straight into fixtures, as we've already said, there's many other tools that you might want to use on a laptop, for example. And of course, you can then very quickly plug your console into your laptop over Ethernet to use maybe visualization software or DMX monitoring software, things like DMX Workshop and things like that, so you can configure your rig. So there's lots of other things that you can connect to when you're using Ethernet. Which leads us quite nicely to, okay, well, how does this all start to piece together? Again, we're looking big picture at the moment. We're not looking at how to configure this yet. So how does it plug together? Well, it uses something called a star topology. When it's DMX, that uses something called a bus topology. I've already mentioned that term daisy chain, how we can daisy chain and loop through our individual fixtures one by one. A little bit different when it comes to Ethernet. And instead it's star. So each device needs its own feed, if you like, from something called a switch. So in the world of Ethernet networking, we have these really useful tools called a switch. And an Ethernet switch is how you can connect all of your devices together. Now, in my example here, I could have my one switch and a feed going from this switch to every single device. I'd end up with loads of Ethernet lines. That's been taken a step further in this example because I've got my Ethernet switch here that then goes to kind of auxiliary Ethernet switches, if you like. Maybe that's our kind of main Ethernet switch side of stage, and I've then got one of these Ethernet switches on each lighting bar. Or I've got one in the dimmer room, for example. And I'm then able to take my Ethernet from here, and then that's going to send an Ethernet line to each device. So in this example here, these lights here might have Ethernet directly on board. And these Ethernet feeds might be going to a gateway to then go into our dimmer packs. So it is slightly different. Something to be aware of though is a lot of fixtures do have an Ethernet in and out. Now that's not like DMX in and out. An Ethernet in and out, if you see that on a fixture, that is actually a mini switch. It's essentially a 3-port switch. The feed coming in, I say going in, you don't really have inputs and outputs, but the connection from your controller, a connection internally to actually get to the fixture itself, and then another one to your through port. So that's kind of what's going on in a fixture. And it allows you to daisy chain the Ethernet signal. Now, you will find, certainly if you're talking on higher channel counts, that if you have lots and lots of these switches being daisy chained, that's going to cause you problems. It's much better to have fewer large switches than lots of switches. So that's just something to be aware of. So let's dive in and take a look at some of those settings then on the console. So that kind of gives us an idea. We've looked there at, okay, what connectors do we use? How do we actually lay this out physically? How do we connect stuff together? But let's talk now a little bit about how we can actually configure this. So if we go back to the console, in your Universes tab, this is where we go to choose what protocol we want to use. So when we're talking DMX, that is talking the physical XLR outputs on the rear of your console. That's what the DMX is referring to. It's enabled by default, so you'll be able to just plug straight in and start using the DMX output. If you do wish to use the streaming ACN or ArtNet protocols, which are DMX over Ethernet, there's a little bit of configuration that we're going to need to do. So we'll take a look and kind of compare these shortly. But if I were to go and enable streaming ACN, for example, you're going to see we get some different options up here. Okay, so we can see here we're going to have to start to configure things like IP addresses. And we'll look at that in a bit. Now, in the fixture schedule, which is the first tab in the setup window, this allows you to filter by universe. So when you add lights into your console, they will appear in here, and these are just quick filters that you can use to filter by universe. So by default, if I enable streaming ACN, any fixtures that are on DMX Universe 1 will be routed to streaming ACN Universe 1. So we get into this situation where we have desk universes and then protocol universes, if you like. Those are different, and you can map those however you want to. So in my case of my desk universe 1 here, I can filter in the fixture schedule to desk universe 1, and anything I see here, if I then go to universes, scroll down to desk universe 1, this is where I can then route that data out of my console. And you can see here, I can choose which protocol universe, streaming ACN and ArtNet, I can choose which streaming ACN universe those fixtures get routed to, if you like. And by default, when we're talking streaming ACN, they will be defaulted to 1. It'll be a 1-to-1 default map, if you like. So anything on Desk Universe 2, anything you've added onto Desk Universe 2, by default will be being sent to streaming ACN Universe 2. But you can configure that. And we'll talk about why you might want to configure that in a bit. So when we enable our protocol, we get these extra settings that appear. So let's explore those. Now, I'm on Phantom Xeros here. And if you're on Phantom Xeros, what you see in the IP settings will be different to what you see on the physical console. Now, when you're on Phantom Xeros is essentially just piggybacking off of your Windows laptop. And so in here, you're going to see the available IP addresses of your laptop, of your computer. So in my case here, I can just see a IP address here, my network address here, which is my Wi-Fi address, and I've also got a network address here, which is the loopback address. If I was also using Ethernet, I'd see a third IP address, which would be my Ethernet IP address. It's what we call NICs, network interfaces. So when you're on Phantom, you just get listed the individual network interface IP addresses. When we're on the console though, we get much more. So if I go and remote into a flex, I've got a flex on my network here that I'm remoted into. If I go and enable streaming ACN on that flex, I get some other IP settings here. You'll see I get a lot more IP settings available. And so you can see I get this option for DHCP, and I get this option for static IP address. If I choose DHCP, a few of these options hide. If I choose static, I get these extra options appear. I get something called an IP address, and I get a subnet mask. And so I need to go in and configure these, because if I don't configure these correctly, doesn't matter what streaming ACN devices you have on your network, you won't be able to talk to them. So when it comes to the world of networking, we do need to do a little bit of configuration to make sure that we can talk to the devices on the network. Let's dive back to the to this information here. So an IP address, that stands for Internet Protocol Address. We're talking IPv4. So there are two IP versions, IPv4 and IPv6. We're purely talking IPv4 at the moment. As you can see, a lot of addresses that are available. These are the essentially theoretical amount of devices that you could have on a network. As you can see, it's a in the world of entertainment lighting, it's a meaningless number. We know we're never going to run out, basically. An IP address, as you might be familiar with, and as we saw here, is represented by 4 numbers separated by dots. These numbers are called octets. So you've got something, 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 something separated by a dot. And an IP address is split into 2 parts. It's split into the network address and something called the host address. So when you see one of those IP addresses, what example did we have there? 192.168.0.88. That IP address will then be split. How will it be split? Well, it's split by the subnet mask. So an IP address and subnet mask, they are intrinsically live together. You can't have an IP address without a subnet mask in the world of IPv4. And they are really important in how they work together. So subnet masks are a way of segregating a network. You could have loads of devices all on one Ethernet network, but you can have only kind of groups of those devices being able to talk each other. Sub-networks, hence the term. And the subnet is what you can use to split the IP address into the network address and host address. Like an IP address, it is also using that same format of being separated into 4 octets, and those are then separated by dots. Now, we're going to keep things simple in this session, and we're just going to talk about subnet masks that are either a 0 or a 255. So what I mean by that is that these values here are either going to be 0s or 255s. So let's take a look. So in my case here, let's say that I've got 2 devices. I've got a device that is 192.168.110, and I've got a device which is 192.168.220. Those are 2 devices. Could be a lighting console, could be a gateway. I could have my gateway and my console that I want to connect to each other in a really simple network. Both of those devices have their IP address and of course subnet. And I've just put the subnet here. Okay. And keeping things big picture, the way it works is essentially you can line up your subnet underneath the IP address visually. Line it up like I've done here in a table visually. And if there is a 255 in an octet of the subnet, so let's say octet number A, the first octet, letter A, sorry, it means that the first octet of the IP of any devices that want to talk to each other must match. So if you get a 255 in an octet, it means that that particular octet of the IP must match. Okay, so if we got a 255, if both of these devices have 255, 255, 2550, it means the first octet must match, 192, yep, they do. The second octet must match as well, because that is also a 255, yep, happy days, 168. And the third octet must match as well. Well, we've now got a problem. So in my example here, if we have 255, 255, 2550, and I had these two devices with the third octet being different, this isn't going to work. These two devices cannot reach each other. So two options I can do to fix this. I could be lazy and just change both of their subnets. And this means now that as long as the first two octets match, the last two can be different. And this is where we're seeing how that subnet is splitting up the network address and the host address. Essentially, this is saying anything in these two here, that is your network address. So in my case, in my example here, these devices are talking to each other on network number 192.168. Where there are zeros in the subnet, that is then the host address. So I've then got two devices. By host, we just mean device number, essentially, if you like, keeping things simple. So in this case here, I've now got device number 110 and 220. If I set this back to 255, I would need to then match my third octet as well. So if I were to set that back to 1, the network address for this particular kind of group of devices to be able to talk is now 192.168.1. All of the devices that want to be able to talk on this group, on this sub network, if you like, have to have that network address of 192.168.1. But then our last octet must be different. So that's another thing to be aware of in the world of networking. You must never have two devices with a matching IP address. That's not going to work. They must have unique addresses. You also can't use a value of 255. So each of these octets are a value from 0 to 255, but you shouldn't use 255 as the last value in the IP. That is reserved. So the maximum I could have is I could have that going from going up to 254. And so these two devices here, if they both share this subnet, if they share that subnet, which is defining that octets A, B and C are the network address, octet D is the host address, as long as A, B and C match and D is different, those devices can talk. So what does this mean from a practical point of view? In a lot of cases, you'll probably end up using this subnet, 255, 255, 255, because of course what that means is you can have over 200 devices still on that sub network. So it's quite unlikely you'll run out. And if you do, well, actually, just go ahead and change that so that this gives you now over 60,000 addresses that you could have on that sub network. So you can use either, but you'll probably find that in most cases you're not going to be using over 200 devices on the network, and so you can quite happily use the 255.255.255.0 subnet, and it just means that those first three octets must match on all devices, and the last one will be different. I hope that makes sense on that. Please do drop us an email if you've got any questions on that, and we can help out. Talking of helping out, that leads us very nicely onto something called DHCP. Dynamic Host Configuration Protocol. Sounds complicated, but it really probably will be your friend, because what it does is it does all of this IP address and subnet management for you. So you could decide, right, okay, well, I've got my console, I've got a handful of gateways around my venue, maybe I've got a laptop that's also on my network, maybe you've got your phone on the network for remote configuration. Well, saving you having to manually enter IP addresses into all of those devices, making sure they're on the right subnet, making sure none of them have duplicate IP addresses. To save you having to do that, you can use a DHCP server. And a DHCP server can just be another device on the network, and it will automatically assign devices, IP addresses, and subnets for you without you needing to do anything. And it's going to make sure that in the process, of course, none of those devices have duplicate IP addresses. There's kind of two trains of thought when they come to DHCP server. Some people really love them because it avoids them having to do any configuration themselves. Some people, though, want to be able to know straight off the top of their head that gateway is that IP address. Well, if you configured it manually, yep, happy days, you know that, you've got it all documented. But if it's a DHCP server doing the work, you're not necessarily going to know what IP addresses your devices are on. The DHCP server is making that decision. So that's just something to be aware of. It is entirely up to you and how you want your network to run. What is a DHCP server? Well, kind of the most simple that you'll have is a kind of bog standard wireless router. So a wireless router, like the one you have at home, but if you were to take a wireless router and plug that into your console, of course it's going to give you first and foremost a wireless access point to allow you to connect your phone. But it's also going to act as a DHCP server, and it's going to be able to dish out these IP addresses to the devices that are on your network. Just something to be aware of, DHCP servers have something called leasing. And that means that when a device joins, and it says, right, I'm not using a static IP address, I need a DHCP address. Is there any DHCP server on the network? The DHCP server can then give it an IP address, and it will have a lease time. And that kind of means that that IP address is reserved. It can't give that IP address to anything else because this device has it. Now, if this device then goes offline, and the DHCP server doesn't see that device for a certain amount of time, and it can be configured on the server. Essentially, that IP address becomes up for grabs again, and it will then might be given to a different device on the network. If a certain device is given a DHCP address, and it then lives on your network permanently, well, that DHCP address is not likely to be changed by the server. It's just going to know, right, well, that IP address is used by that device is still online, so it's just going to keep that IP address. I've just put another bullet point there to be aware of. If you see you have one of your devices on the network with a 169.254 address, and you think, what on earth is going on there? I haven't configured that. That means that your device is configured to receive a DHCP IP address, but there isn't a DHCP server on the network. So that is exactly what would happen to your laptop, for example, if you plugged it straight into your console. If you plug your laptop straight into your console over the network, by default, your laptop is waiting for a DHCP address, and it won't get one because your console is not a DHCP server. And so it's just going to be sat there with what we call a linked local address, 169.254, and it's not going to be able to talk to your console if your console is set to something like this. So that would require you, if you're connecting your laptop and your console straight together, it would require you to go and configure the IP on both the laptop and the console. If you've got it as part of a larger network with a DHCP server, as I said, you might make that decision to actually set everything to DHCP so that the server's doing the work, defining what device is on what IP address. So that is our network settings, and as we saw here, so that is why we can see an IP address and a subnet mask. So in my example here, 192.168.0, that is my network address, because I've got a subnet of 255.255.255. 88, that is the host address. So I can now talk to any devices on my network that have an IP address of 192.168.0, sharing the subnet mask, but with a different, unique last value of their IP address. So I could have a gateway 8 on 192.168.0.89, and I'd be able to talk to it. Or I go DHCP, and as I've said, my console's then just sat there waiting for a DHCP server on your network to give it an address. And likewise, if you have a gateway configured to DHCP, the DHCP server is going to go, okay, well, I'll give this address to the console, I'll give it this address to the gateway. They're going to be able to talk to each other. So that's a bit of the theoretical side. We've gone quite in depth there in parts on how we can actually configure our network to work. When we've got this knowledge under our belt, okay, well, why would I use streaming ACN over ArtNet? Why do they both exist? I've got streaming ACN, I've got ArtNet. Both of them consist of these IP options. How do I choose which to use? Which is right for me, and why? Let's take a look at streaming ACN then. Streaming ACN is DMX over Ethernet. Streaming ACN is the standard. It's an ANSI standard for DMX over Ethernet. Okay. And it is, as we've said, it is just literally DMX over Ethernet, nothing else. As you can see there, one line of DMX, that's one universe. One line of Ethernet running streaming ACN, we can have thousands of universes. Now, this is theoretical. You would need some pretty hefty networking gear to be able to run that kind of volume of universes. But you know, if we're talking on a 16 universe flex, for example, you're going to be absolutely able to pack those 16 universes of data, no problem at all. Now, one of the big benefits of streaming ACN is it has the support for multiple controllers, because it has something called prioritization. So if we go back to Zeros, I'm going to minimize that. If we go back to Zeros, you'll see that we have a priority option. And that is the default priority of all of the universes being sent from your console. And it is just a number between 0 and 200. 200 being the highest priority, 0 being the lowest. And so you could have multiple flex consoles on your network if you wanted to, all of them controlling the same rig, but whichever one has the highest priority, that's the one that will have control at that point in time. So this is the default priority of all of the streaming ACN universes being sent from your console. But for whatever reason, you could say, okay, well, actually the stuff that I'm sending on universe 2, that cannot be overwritten by any other console on my network. So I could actually go to Des Universe 2, and I could give that a custom priority. So I could go and say, actually, streaming ACN Universe 2 being sent from my console, that is going to have the highest priority. Or if I want, I can go and set it back to default, and that will then use whatever the default priority is that I've set. Now, equally in here, as I've said already, it's mapped one-to-one. But I could say, actually, the stuff that's patched on Desk Universe 2, I need that routed to Streaming ACN Universe number 2, and also Streaming ACN Universe number 102, for example. And I can start to add multiple Streaming ACN universes, and all of these Streaming ACN universes are going to be sending whatever has been patched onto Desk Universe 2 on my console in this example. And so I can have multiple Streaming ACN universes all sending the same data from my console if I wish to. Now, when you end up in the situation like this, where you've got all sorts of extra universes added, you can go and reset to defaults. And if you reset to defaults, that's going to tidy it all up. I can do the same with ArtNet. And so that's just something to be aware of. If we dive back to this, something else that Streaming ACN has is something called a preview mode as well. Just another feature to be aware of. And it will also support synchronization. So Streaming ACN has the ability to make sure that on very, very large networks, it can make sure that all data arrives to all devices at the same point, for example. So that's Streaming ACN. Multiple universes over our Ethernet network. ArtNet, a little bit different. Technically, it is not a standard. It's owned and copyright by Artistic License, which are a company based in the UK. But it's free of charge and royalty free. The standard is readily available from their website. You just need to basically say, look, it's ArtNet 4 from Artistic License. Why ArtNet 4? Well, there's been multiple revisions of ArtNet over the years. ArtNet 4 is the latest revision, and that is the revision that is supported by your Xeros console. ArtNet 4 has got a maximum limit of 32,768 universes. So don't worry, you're still not going to run out in a hurry. And again, a little bit theoretical in the fact that if you're starting to talk that volume of data, you're really going to need to think about high throughput networking equipment. Again, though, if you're talking 16 universes, you're going to be fine. Or pretty much whatever networking equipment you have, to be honest. Now, this is where a key difference comes in with ArtNet. ArtNet supports RDM over Ethernet as well. Streaming ACN is just DMX over Ethernet. ArtNet is DMX and RDM over the network. And that allows you to discover and configure devices remotely using the ArtNet protocol. As well as that, it means that RigSync works over the network. If you're not familiar with RigSync, go check out some of our other sessions on RigSync. That is our implementation of RDM. So ArtNet, one of the big benefits of ArtNet is you've got remote configuration available to you. Both in terms of configuring the devices that are on your network, but also using RigSync to actually configure fixtures remotely as well. So let's see that in action. If I go to my console, and I'm going to go and enable ArtNet, something to be aware of with IP address, yes, we have DHCP and we have static, but on ArtNet we have two other IP addresses as well. They are predefined IP addresses automatically generated by your console, and they are a primary or a secondary address starting at 2 dot or 10 dot, automatically generated by the console. And they allow you to be lazy, basically, because a lot of ArtNet devices default to a 2 dot something 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 or 10 dot something 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 IP address. And so you can use either the primary or the secondary address to straight away get connected to those devices. Or you can configure a static or a DHCP. Now, in my case here, I have a gateway that is set to a DHCP on my network. So if I go to my ArtNet and configure DHCP, I'll be able to now talk to that device. And so if I go to devices in your console, this is going to show me any devices on my network. And I can indeed see that I have a gateway 4 on my network. In brackets, I have the IP address. Again, I didn't configure that IP address. That's the DHCP address that the DHCP server on my network has given the gateway. Over ArtNet, as I said, you can discover your devices, but you can configure them as well. So first of all, I could give it a name. So I could call it 088 Gateway 4 left, for example. And so if I've got a stage left and a stage right, I can very quickly see on my console which is which. Taking that a step further though, I can then configure the outputs remotely. So we've kind of got 3 stages of configuration. We've talked about the first 2 already. And those are, first of all, you patch lights into your console onto a universe. You then go to universes and choose how those desk universes get routed from your console. So I could choose to, for example, route desk universe 1 to ArtNet universe 0, for example. If I go and reset my ArtNet to defaults and start at 1, that's going to be mapped now 1 to 1. So ArtNet 4, universe 1, that is sending desk universe 1. So anything on desk universe 1 is getting routed to ArtNet universe 4. I can then go to my devices and I can now see that port 1 is set to transmit ArtNet 1. So I know whatever I've configured to my universes here. So ArtNet 4 is sending universe 1. I can see that mapped here. But I could map it differently. Again, if I've got my stage left and my stage right gateways, stage left might be receiving ArtNets 1, 2, 3 and 4, but my other gateway might be actually needing to send at 5, 6, 7 and 8. So I could go and configure that in here. So I could go and say, right, actually I'm going to go and say 5, 6, 7 and 8. And so now the ports on that gateway are outputting those ArtNet universes. So that means actually in my universes tab now, I'm going to be sending desk universe 5, 6, 7 and 8 to those ports. If I wanted to, I could configure my gateway a little bit like a splitter, because I can add multiple universes. So if I were to put these back to 1, 2, 3 and 4, I've got those set to 1, 2, 3 and 4 now. And let's say that I want them all of those ports to output desk universe 1. Well, I've kind of got 2 options. I could go and set them all to be ArtNet 1, or I could go to universes and I could actually add multiple universes in here. So I could go and say, I want this to be 4. It's going to say this universe is already be used by another desk universe, so I can say use on this one instead. And I can just go through. And now, anything patched on desk universe 1 is getting routed to ArtNet 1, 2, 3 and 4. And my gateway is outputting 1, 2, 3 and 4. And so it's going to output that data. So you've kind of got these 3 stages of configuration. You've got actually adding your lights into the console onto the desk universe, routing that desk universe out onto your protocol universes, and then using ArtNet, you can then define which port is going to output which protocol universe. Now, you may have noticed in here that I can configure a port to output streaming ACN. Now, you remember, I said streaming ACN is DMX over Ethernet only. It is no configuration. ArtNet, on the other hand, is DMX and the configuration side of things. But if I want, I can mix and match. Because I could say, well, I want the streaming ACN for my DMX over Ethernet, but I don't want to miss out on the configuration side of things. So what I could do is I could go and say, yep, I want to use streaming ACN. I'm using streaming ACN for my DMX over Ethernet. And I could actually go into my desk universes. I'm actually going to go to ArtNet, reset, but I'm actually then going to remove my ArtNet universes. I could say that actually I don't want these desk universes being sent over ArtNet. So I can go and remove those ArtNet universes. So now I've done that, although my console is not sending these universes over ArtNet, it is sending them over streaming ACN. And so, but I can still see this device because I'm still using ArtNet for the configuration side of things. So I could now go and say that I want these ports to output streaming ACN. And now I am not using ArtNet for my DMX. I am purely using ArtNet for my configuration, and now my DMX over Ethernet is still being done over the streaming ACN protocol. Meaning you've got that benefit of the prioritization. Best of both worlds. You've got the configuration and you can use the prioritization because you're using ArtNet for configuration and you're using the streaming ACN for the actual DMX over Ethernet side of things. And that is everything that I wanted to go through in this session. I hope you found it useful. We've gone through lots of aspects there. We've spoken about how we can actually configure our network. We can build it ourselves using our networking equipment and our switches and our network cabling. We've talked about IP addressing as well, how we can configure network addresses to be within range of each other. And we've also spoken about how DHCP can help us out. And then we've looked at how we can actually configure our streaming ACN and our ArtNet on our console. And we can choose which protocol we want to use. And when we've done that, we can go down and actually define how our desk universes get routed to those protocol universes. So I hope you found it useful. If you do have any questions at all, please do drop us an email to support@088.com and we'll get back to you. And I hope to see you on the next session. Thank you for joining.